Hello again, everybody. This is our video solution to problem 4 from Quiz 2, Fall 2023, Math 307, Linear Algebra at Cal State Fullerton. In this video, we're going to look at a problem where we remember that Dr. G is human. So in lecture, I incorrectly wrote, very briefly, but I did write it, a list L of vectors of V is linearly independent if every element of V has a unique L representation. So just a brief reminder, if I have a list, so if L is equal to, say, V1 through Vn, and I have an element in the vector space, so say V is in V, well, I'll use a different letter, how about W is in V, then an L representation of W is a linear combination of the V1 through Vn's that equals W, right? So this would mean W is equal to AI VI. So here I'm using the Einstein summation convention. So this, remember, means that I'm actually adding, right? I goes from 1 to n here, A sub I, and it doesn't matter whether I use an upper or lower index. Okay, so, but for the convention, of course, we use the upper index to show that we're summing over I. Okay, so this would be an L representation of W. And linear independence means if every element, right, has a unique L representation. All right, but there's a key preposition or prepositional phrase I missed here, right? Okay, it's this of V that's problematic. If you have a list that spans V, then every element in V will have an L representation. But if it doesn't span V, then there will be some element that doesn't even have a single representation, much less a unique one. All right? So you cannot say here, right, that every element of V has a unique L representation. Instead, and this is what we corrected it to in class, every element of the span of L. All right? So you only look at things that actually do have a representation. As soon as you know that it has a representation, you can ask, is it the only one? And linear independence says, you betcha, that's the only way to do it. So the correct definition is that a list of vectors is linearly independent if every element of its span has a unique representation. So there we go. All right, we will see you next time.